So for section 8.2, we're going to be focusing on and statements and or statements. And what I find people get confused on is one of these is inclusive and one of these is exclusive. And I'll give you a hint, it's probably opposite than what you think. Okay? So inclusive means you're including more and more and more, and exclusive means you're restricting to a smaller group. Okay? And so most people will guess, well, yeah, and is like you're including this and this and this, but that's not how it works here. And is actually more exclusive. And here's how we know that, right? If I was to say, all right, let's look around the classroom and say, how many people in here are male? And all the males would raise their hand. And I'd say, okay, how many in here are male and wearing sandals? Well, what just happened? That and excluded, and we would only have males and people wearing sandals. You'd have to be both to keep your hands up. Okay? So it excludes. It is restrictive. Okay? Both must be true. To be included. If I said how many people in here are, female and wearing earrings, the only females raising their hands would be ones wearing earrings. If I said how many people in here are male and female, ideally nobody should be raising their hands as far as I know, but the idea is what? Both must be true, and it's either one or the other, and so that would be restrictive, okay? Exclusive. It is one or the other, okay? Or is more inclusive. If I said how many people in here are male or wearing sandals, well, all the guys would raise their hands, and anyone wearing sandals. See, it would include more. Male or sandals would be all the males and all the people wearing sandals, including females wearing sandals. So it would be more inclusive. Okay. So for it to be or, it's either one is true or the other is true. And you're included in that group. So or is more exclusive. The other example I like to give for this is if you think about, you talk to these girls and they go, oh, the perfect guy, right? They go, oh, he's this and this and this and tall and handsome and drives a nice car and what's happening is they're using that and is the group is getting smaller, like to the point where he no longer exists. I know, but the idea is it is exclusive, and you should be exclusive because you don't want to sit there and say, well, the perfect guy could be this or tall or short or, it's just anything will do. Well, that's not how you want to choose a person to have a relationship with. You want to be exclusive, right? So just keep in mind, and is exclusive. Both must be true. You have a smaller group. Or is inclusive. Either one is true, and this is a larger group. Okay. Here are three groups. A is a set of numbers, -3, -1, 0, 4, and 5. B is the set of numbers, -1, 3, and 5. C is the set of numbers 0. The first one, I forgot to put the symbols. All right, we'll do that real quick. And, this is the symbol we use for and. Or, this is the symbol we use for or. Okay. So, for it to be A and B, that's what this is saying, A and B, I'm looking for numbers that are in both A and B. Well, what do they have in common? Well, it looks like they have a -1, 3, a 5. So if I'm saying A and B, the answer would be the set of numbers, I can do better than that, so the set of numbers that are just -1 and 5. That is the only overlap there. Now, if I said A or B, what does that mean? Well, that's everything in A and everything in B. It's one or the other. So that would be the set of numbers starting at -3, -1. I don't need to write that -1 twice because we've already counted that. That's just that would be the guy wearing sandals. He's not going to raise two hands just because he's a guy wearing sandals. you know, he only has to raise one hand. That negative 1 is in both groups. Then it would be 0, 3, 4, and 5. And once again, I do not have to write the 5 more than once. It's just all of the numbers. It is more inclusive. What if I said A and C? Well, what do A and C have in common? The only number they have in common is 0. So it would be the set of numbers 0. What if I said B and C? Well, what do B and C have in common? Well, C has a 0. B does not. So this would be where we would put not a 0. This is where we put a 0 with a line through it. Basically, that stands for an empty set. There are no numbers. See, this is where I've been asking people not to put lines through their zeros, because they're like, well, it never matters. Well, here it matters. 0 here stands for something. It means the number 0 is between the two. This 0 with a line through it is telling me it is an empty set. There is nothing in there. 0 is something. 0 with a line through it stands for nothing, empty set. Okay? And B or C. B or C would basically mean everything from B, everything from C. So that would include the negative 1, 0, 3, 5. So B or C, negative 1, 0, 3, 5. How does this apply to what we've been doing, which is solving linear equations and inequalities? Well, here is an AND statement, okay? How would we solve this? Well, we solve each one separately. So I solve the one on the left. 2x greater than or equal to 6. X is greater than or equal to 3. And this one, x is less than or equal to negative 10. Well, what does this look like? Well, I am looking for numbers that are greater than or equal to 3. So here's 0, 1, 2, 3. Greater than or equal to 3 is a bracket shaded to the right. Less than or equal to 10, negative 10, sorry, would be way over here. Less than or equal to would be a bracket also shaded to the left here, okay? So is this our answer? No. Because this is an AND statement, what this means is for us to shade it, it must be true. Give me a number that's both greater than 3 and less than negative 10. There is no number. So this would be an example in your homework of an empty set. So we write that as an empty line, okay? Well, what if I wanted to keep that answer? Well, that's easy. All I would do is take the same question and change it to an OR. Because what happens here is I end up with x is greater than or equal to 3, or x is less than or equal to negative 10. So who gets included this time? Well, all right, looks like I squeezed it in here. So that would be 1, 2, 3, bracket and to the right, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, bracket to the left. This would be true because OR is inclusive. It could be one or the other to be true. So we would include all the numbers greater than or equal to 3, and we would include all the numbers less than or equal to negative 10. OR is inclusive. Okay. The only other thing we have to do on this is we do have to still know how to do interval notation. Because what happened here is we end up with two intervals. I end up with an interval going from negative infinity to negative 10. Just like we did before, the infinity has a parenthesis, the 10 has a bracket. I also have the interval, a second interval, going from 3 to infinity, the 3 having a bracket, the infinity having a parenthesis. But what we have to do between these is we have to say it can either be this or this. So how do we do that? We put the symbol. So just like before, we need to be able to get the algebraic solution. I can spell. Algebraic. Then we need to be able to graph that solution, and then we need to be able to do the interval. So all three of them, okay? This also gives us kind of a nice hint that I'm going to start adding up here right now. ORs tend to look like this. You'll have 2 points. You'll have x is less than a, or x is greater than b. ORs tend to look like this, where I have an A, I have a B, and they shade outward. Okay? Well, why? Well, that's including all the numbers greater than B and all the numbers less than A. That's an OR. Okay? That is inclusive. On the top, an AND, we have to have an overlap for it to be true. So this would be something like x is greater than A and x is less than B. So we have some number A, some number B, and the AND says we have to keep only the overlap. So greater than the A, less than the B, only the middle is kept. That makes it an AND statement. Okay? So they tend to look like this. Now we just saw a contradiction of this where an AND went outward. And what did that mean? Well, there was no overlap, so it was an empty set. Okay? We'll deal with more of that as we keep going. So for now, just know that the ANDs tend to be shaded in the middle, ORs tend to be shaded on the outside. We'll look at some exceptions at the end here. Next one. Pretty easy to solve. Let's go ahead and divide everything by a 3 so that x is less than 17/3. Okay, well that's going to be fun to graph. Or 2x is greater than negative 17 over 2 over 2. X is greater than negative 17 over 2. To keep the algebraic solution, to get full credit for it, bring both statements down together and either use the word or the symbol OR, and that will be your first answer. Okay? So bring them down together and write them as a complete statement with either the words or the symbol OR. The graph. Let's see. X is less than 17/3. I'm going to put that in my calculator, hit enter. It's going to give me 5.666. So basically between 5 and 6. So 1, 2, 3, 4, 5, 6. Between 5 and 6, somewhere in there is 17/3. And it's shading what direction? To the left. This is x is greater than negative 17/2. I'm going to put that in my calculator, hit enter. It's going to give me negative 8.5. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Between negative 8 and negative 9 would be negative 17/2. And that is there and to the right. So the question is, do I just keep the middle this time? Well, it was an OR, right? So technically, it is everything to the left, everything to the right, and the overlap. OR is more inclusive. So this ends up being a complete line. So where did we shade this? Well, basically from negative infinity to positive infinity. We shaded everything because I want something that is less than a positive number or greater than a negative number. That would be any number. Okay? So how do I deal with this? If that question had been, 1 second. If we had ended up with x is less than 17/3 and x is greater than negative 17/2, we would have the same picture, but this time we would only keep the middle. And why is that? Because an AND is more restrictive. Okay, so we would end up with only the middle of those two. How would we do that interval? I would just write it as a single interval. I don't have two intervals there. So I would write the interval as a minimum of negative 17 halves and a maximum of 17 thirds. Okay, and that is more restrictive. The book will sometimes go, okay, go from negative 17 halves to infinity, to the right forever. Go from negative infinity to 17 thirds, but only keep the overlap, so then they'll put an and in the middle. Either of those are fine. I prefer the one on the top. The homework, I think, sometimes does the bottom one. Whatever you're most comfortable with, I'm fine. Either of those are correct. How do we solve this? We're going to add 7. Negative 4x greater than or equal to 12. This time as I divide by the negative 4, I get that x is less than or equal to negative 3, and, let's do the one on the right, negative 3x is less than negative 15. That gives me x is, flip it, greater than positive 5. So what do we have here? Negative 3, positive 5. Left, right, but I'm looking for an and, which means I'm looking for an overlap. Is there an overlap? And is the overlap. There has to be both for it to be true. Can I have a number that's less than a negative and greater than a positive? No. This would be an empty set. If I took that same example and I made it an or, well, we would end up with x is less than, did I mess up on that? Sorry, I actually want this to be the same example, so let me do that. Sorry about that. Alright, then I'm going to end up with x is less than or equal to negative 3, and on this one, when it flips, x is greater than 5. This time it's with an or. Well, I'm going to graph it the same. So less than negative 3, greater than 5. Let's see, the less than needed a bracket. Sorry about that. But this time it's an or, which means what? Ors tend to go outward. So one or the other is true. So this is our graph. And you have to have an overlap. This didn't have an overlap, so it was empty. Or it can be one or the other. It is less restrictive. How would we do the interval? I see two intervals, from negative infinity to negative 3, parenthesis bracket, from 5 to infinity, and in the middle we have an or. Do a couple more. I have plenty of examples on this because I know these tend to be a little trickier. The first part's really the easy part. They give us some sets and we find the overlap or inclusive. This tends to be a little trickier, but let's see how we do. So let's go ahead and solve this. 3x less than or equal to negative 6. X is less than or equal to negative 2. Or x is greater than positive 5. The graph for this, less than or equal to negative 2, bracket, shaded to the left, greater than 5, parenthesis. Now in this situation, I'm looking at it, and this is fine. It is an or. Ors tend to go outward. This is fine. It could be one or the other. How do I write that interval? From negative infinity to negative 2. parenthesis bracket, or from 5 to infinity. And that's it. That's all we would do on that. This next one, if I divide by the -1, that's going to make that x turn positive, that 1 turn positive, and the inequality is going to flip, or here I'm going to add 8 and get x is greater than -3. So how do we graph this? Well, x is less than 1, or x is greater than -3. Well, less than or equal to 1 would be this. Greater than -3 would be this. What happened? Well, this isn't an and, so I'm not going to only keep the overlap. This is an or. We include everything. So this basically goes from -infinity to infinity. And why? Because it is an or statement. So this could be the males, or the sandals, or the males wearing sandals still are included, or is inclusive. Okay? These are special cases. They show up in the homework. I'm not going to have like a bunch of these on the test, but I want you to see the special cases because they pop up in the homework and I don't want you to get frustrated. My initial notes, ors tend to go outward, ands tend to be just the overlap in the middle. They don't always have to be. Okay? So case in point, last example. Same exact question, but I've now made it an and. So what does that do? X is less than or equal to +1, and x is greater than -3. Well, this time, I'm still doing less than or equal to 1, and I'm still doing greater than the -3. But this time, I'm not keeping everything to the right and everything to the left. We're only keeping the and, so we're only keeping the overlap in the middle. That's restrictive. That is our and. So our interval, and this is kind of and I would just put the interval as a minimum and a maximum. I'm pretty sure the homework makes this some two statements. I don't really care for that, but it's not wrong to say, well, we went from -3 to infinity, and we went from -infinity to 1, but we only kept the overlap, so make it an and. I prefer the one on the top. To me, it's a little easier. Sometimes I'll write the one on the bottom. It's not wrong. It means the same thing because the and says I'm just keeping the overlap. Here, I just wrote what the overlap was.